This is the Whiteside SB25-2, and it's a surfacing bit that has carbide inserts. Comes with some more extra carbide inserts. Let me go ahead and open it up. I haven't taken the wax coating off of it just yet, but this is for flattening slabs and Spoilboard and all that good stuff. It is manufactured by Whiteside, but Bits and Bits company adds an Astra coating to these carbide inserts to make them last a little bit longer, well, a lot longer actually. Every bit that I've had from Bits and Bits that has this Astra coating, it lasts forever, it seems like. I don't go through bits hardly as often. So we still have a little bit of this oil coating. What else do we have on here? Max RPM of 14,500. That's important. You don't want this spinning chunk of metal to go too fast. But as you can see, I just took the coating off of it, the wax coating, for shipping. So I have yet to actually use this and see how it performs. So that's the goal of this video. Like I said, it comes with a set of carbide inserts that are replacement. And I believe there is 10 pieces in this. Oop, upside down, right side up. Oh, I got it right. 10 pieces in here. Now each one of these carbide inserts has 4 cutting faces, 4 cutting edges. So that means you have 10, you have 2, that's 12 divided by 2 per setup. You have 6 setups. Each setup has 4 cutting edges. So you have, what's that, 24 fresh cutting edges in this combination right here. That's pretty cool. So if you notice it getting dull, you can swap it out. Carbide inserts are the way to go. They're just the way to go for all tooling. Since I got my first carbide insert on my joiner, it just makes such a difference. It's quality cuts, much greater quality cuts than like high-speed steel, and they last so much longer. All right, I gotta quit playing around. Let's put a slab on here and make some cuts. Whee! This is a hickory slab. It's like 3 inches thick that I got from my friend Sean Stone years ago, and this was supposed to be table legs, but I ended up not making that table. So I've been using it to test flattening bits on the CNC. Of course, one of these days I'll get around to actually turning this into a project, but in the meantime, it serves as a really good benchmark material. I can keep cutting this and use it as a benchmark for how different bits perform. Clamping down a large slab like this is very basic. You don't need a top-down clamp to hold it to the table. It's heavy enough where it's not going to lift off. Luckily, on the other side, I've already flattened it a little bit, so that helps without any rock or whatever. But if there is a rock or a twist, I'll put a wedge. Let's just say it's high on that side and this side, so it's rocking back and forth left to right from corner to corner in this orientation. What you would do is you put a wedge over here and a wedge over here to kind of meet the distance or break the distance, so it's balanced, and then you can either clamp it down from the top or just put some stops all the way around it. I always, for these bigger slabs, always just put stops around it. It's too heavy, it's not going to walk around on you. Just stop it from wiggling, basically. So bench dogs for the initial locating, 1, 2, 3, and this one right here stops it from going in this direction. These bench dogs and these clamps stop it from coming towards me. I've got these wider stops over there, and then some clamps over there as stops as well. Not only am I testing how well the bit actually cuts, in hickory nonetheless. Hickory is a nice dense hardwood, so it's a good test for it rather than pine. You know, pine, any bit can blow through pine basically. But we're going to test it in a nice hardwood. We're testing the bit, but we're also testing the spindle. Can this spindle handle this? I have the upgraded spindle I've yet to install, so this will also give me a good baseline for when I install the upgraded spindle. This is an Avid CNC being controlled by Mach 4. And Mach 4 has the option, Avid has the recommendation to warm up the spindle, run a spindle warm-up procedure. This is going to put a lot of stress on the spindle, so I am going to run the warm-up procedure, warm up the spindle, but I don't want this big old bit flying around me, and I really should have done this with the collet off. So what I'm going to do is I'm going to move this all the way over here away from me and run the warm-up procedure while I work on the VCarve file to get this going. That should be good. And I can run the, yep, that's fine. Run the warm-up procedure over there while I work over here. Testing time, and for this I don't have a recommended feeds and speeds from the manufacturer, Whiteside, or from the retailer, Bits and Bits, for this particular bit, and that's somewhat expected. You'd like to have a good starting point, but it's somewhat expected to not have those because different machines have different capabilities, and of course you're using different materials, so I understand it when some information is not available. So what I do in this case is I find a bit online that has either identical or very similar geometry, and I use those feeds and speeds, if I can find any, as a good starting point. And what I did is I did find something that recommended this size to have an RPM of 12,000 RPM, 110 inches per minute, with a chip load of 0.0031 inches. Well, I put that information in VCarve, and VCarve gives you a chip load calculator, or it shows a chip load calculator, and that exact information was not 0.0031 inches, it was 0.0046 inches, so it's taking a much bigger bite than what is recommended. But what I don't know is the initial information that I found. What's the pass per cut? What's the depth per pass? And also, what's the step over? Is that taking into consideration a half pass, or is that taking into consideration a full width pass? I think it's a full width pass is what they're calculated as. But I don't know that information from the original information that I found, and I don't know what VCarve is using for the depth per pass to calculate that either, because if I change the depth per pass in VCarve, the chip load doesn't change. So this information is a good starting point, but what I'm going to do is I'm going to set those values not in VCarve, but I'm going to set those values in Mach 4 so I can manually jog it at the RPM and the feed rate recommended, and then I can use that information combined with using the MDI, manual data input, to drop down a specific height and hog off material and visually see the feedback. What does it sound like? Does it sound like it's stalling? Does it sound like it's just plowing through it with no effort whatsoever? And from that, I'm going to determine my feeds and speeds for this bit on my machine. And once I get that done, I'll show you what it looks like. All right, so I did a bunch of testing and got a bunch of different results. Here's the chips from the test, right? So this is what we're looking for, larger chips, not dust. This is an efficient material removal. So 110 inches per minute, 14,500 RPM, the max of the bit, 0.125 inches depth per cut, so 1/8 of an inch depth of cut, and about a 2/3 step over. I was shooting for 2/3, but I was just eyeballing it. So 2/3 step over, that would give me a 1.65 inch width of cut per pass. And you see this step right here. This was initially a 1/4 inch depth of cut, and I was trying to do a 1/4 inch, but it's just too much for a wide step over. And I don't like setting up for a narrow step over, because if I'm trying to achieve a narrow step over, every time I start my cut, sometimes the first cut will be a full width cut, and I'll have to slow down the machine in Mach to take care of that, and then bump it back up to 100% or so. And every time it completes a layer and then goes back down another layer, I have to do that. I have to babysit it and stop it. So I'm not going to try for a deeper cut with a narrow step over. Instead, I want to get a decent sized step over with a decent size depth of cut. So this was just removing too deep, so I stopped here and then went back to my 1/8 of an inch depth of cut from here. So this is a 1/8 of an inch step, and this is what I settled on. And really, 1/8 of an inch depth of cut at about 2/3 step over 110 inches per minute, 14,500 RPM. When it hit this knot over here, I had to manually slow it down as well. So this isn't foolproof. You're gonna have some super hard spots that you have to babysit as well. So that's where I'm at. I think I'm going to settle on these numbers and then I guess tweak it as the project, on a per project basis. You know, if I'm using lighter material, less dense material, I can of course increase the depth of cut or increase the inches per minute to keep that same chip load. I can't change the RPM any higher than 14,500. So in this case, I'll have to adjust the depth of cut in inches per minute. Also, I put the dust shoe on, but man, it didn't do that good of a job. The bottom of the router bit is just a little bit lower than the bottom of the brushes on my dust shoe, and I can't put it up inside the collet any higher. So, is what it is. I'm gonna take it off, put a face shield on, and show you how much dust throws all over the place. Running that without the dust shoe on was brutal. There was dust everywhere. And most of it, like I said, is the good quality chips and shavings that you're supposed to get. But I don't know if the camera's going to show up. This left side is kind of spalted and spongy, and there's a lot of wormholes and crap in here. So it was throwing some dust as well. When it got over to here to this good quality stuff, it was throwing chips. Anyway, I've got my air cleaner cart running, my exhaust fan going, and the door behind me open. I'm going to take a break and let this air out for a good 20-30 minutes. It is dusty in here. Let's wrap this up with 4 main takeaways from this video. First is this bit now allows me to have provides me with the fastest waste removal option that I've ever had. That removes a lot of material, and I like that for slab flattening. Tongue-tied. Number 2, this is the best surface finish off of any router bit that I've ever had in my shop. And it's no surprise because this is basically like turning the CNC machine into a planer, right? And every machine that I've had with a helical head or spiral head jointer planer with carbide inserts, the surface finish is ridiculously smooth compared to straight knives. And that's basically a giant planer. So I'm going to show you a little cell phone video of the surface quality or the surface finish right off of the bit. I've got the door open just so you can see the reflection on this board. This is right off of the carbide insert cutter. That's incredible. That is so smooth. Right off the machine. I can't get over that. I've never had a surface finish like that off of a router bit. This exact piece of wood, if I was to use this as a tabletop, dining table or a sofa table, something, if I was to use this as a tabletop right now, I would be satisfied taking this off the machine, hitting it with a card scraper, and calling the top surface done. The surface finish off of that bit is incredible. I'm blown away by that. And then again, I really shouldn't be, because it's a carbide insert cutting surface. This is basically like a giant planer in this operation, and I really shouldn't be surprised, because I've had a carbide insert jointer. That was my first step into the carbide insert cutting heads, and that was a huge eye-opener. The surface quality off of that, it was incredible. And then now I have my jointer planer combo that has both, well, for both jointing and planing, carbide inserts, and it definitely is the way to go for those machines. And I'm now learning that it's definitely the way to go for planing on a CNC machine. That's incredible, the surface finish. Results, Third thing on my list is the Whiteside SB25-2 Astra coated. That's the bit. I now have the specs, so I can put it in my tool arsenal and run it. Best flattening bit I've ever used. And the fourth thing, which is really, really good for my exact scenario, is I do have a baseline for my spindle upgrade that I'm about to do. So this particular spindle that I'm using is the old Avid spindle. It's a 2.2 kilowatt. I forget the horsepower on that, so we'll stick to kilowatt. 2.2 kilowatt, and I'm upgrading to the 6.75 kilowatt 3-phase. Unfortunately, I don't have 3-phase here, so I can still run it off a 240 volt single phase. But that'll drop it down to 4.7 kilowatts, which is about 6.4 horsepower. So I'm going from 2.2 kilowatts to 4.7, so a little bit more than double the power. And once I get the upgrade installed, I can run the same test again and see if I can't tweak it a little bit more, and it'll give me a good baseline of how much performance gain there is by swapping out the spindle. That's it for this video. You guys take care, have a great day, and I'll talk to you in the next video.